Good day to you all, grade 12s and the viewers. I hope you're all good. And in this video, as requested, I'm going to show you how to prove proportionality theorem. It's a grade 12 theorem, this one, under Euclidean geometry. All right. Of course, if you need some further helps, do not hesitate to hit me on my WhatsApp or to contact me there on the number below. All right. So I'm going to show you how to prove this theorem for grade 12. Just stay tuned and enjoy the video, right? Since I'll be giving you the entire proof, whereby you can able to grab these marks, right? 5 marks or 6 marks, right? The marks allocations for this one, if you're lucky, you find that maybe they're awarding you 6 marks for just proving it, but normally they use 5 marks, right, for you to prove this. Okay, so let's just go through it in detail and see what it is needed here. Prove the theorem that a line parallel to one side of a triangle divides the other sides proportionally in the same ratio, right? So what you are going to see on your exam paper, right, they will just give you the diagram and something like this, right? They will need you to prove that AD divided by DB, it is equal to AE divided by EC, right? Together with this triangle here, empty triangle like this here. All right. So the first thing for you to do is to do the construction, right? Is to do the construction. Let me write it here. Underneath, you need to apply the construction. So on your construction, the first thing for you to do is to draw the altitude. Let me write it here. Draw altitude h that is perpendicular to the line AD, and altitude sorry for that, sorry about my handwriting. The altitude K that must be perpendicular to AE. Okay, you need to do the construction. This must be the first point on your construction, right? So whatever you're constructing here, you need to go and apply it on your given triangle there, right? Okay, so let me select another pen here to draw this altitude. The first altitude for me to indicate is the altitude h, and this altitude h must be perpendicular to the line AD, right? Okay, let's go and check. Whatever I'm referring now here, I'm going to, whatever that I'm going to do now here, I'm going to refer on this triangle, right? In this triangle ADE. Okay, I'm going to refer on this triangle ADE here, right? So let me draw the altitude h that is perpendicular to the line AD. This is my line AD from A to here is the line AD. So the altitude that I'm going to draw, I must start it from here at point C, and it have to be perpendicular. Perpendicular, remember, it must form the 90 degrees to this AD, right? So, and I denote this altitude be the H here. So this is my altitude H, all right? Then the next one, I'm going to draw another altitude, which is the K, and the K, it must be perpendicular to this line AE, right? So this altitude, I'm going to draw it from the point D, right? Pointing the line AE. I'm going to move here. Oh, sorry, I want to use a different pen here so that it can really make sense. Let me just choose this one. I draw the altitude going there. This altitude, I'm going to denote it as the K, right? Okay, I'm done with the first construction, right, for drawing the altitude. So I'm going to show you the next part to do, still under construction, right? Under construction, the number 2, I need to draw the BE and CD to form triangle, which is BDE and triangle, which is CED. All right, here we go. You can check here, right, guys? I'm going to move slow here so that it can this presentation can favor you all, guys. All right, so we need to draw the line, which is this BE and CD, to form the triangle, which is the BDE, and the triangle, which is the CED, right? So let's go and apply it practically there, right? We need to apply it practically. Let's go back on our diagram, okay? So on our diagram, I have to draw the line, which is BE. So you need just to join B to E, or E to B. I'm going to join it. Here it is, right? I'm joining there, and then after that, I'm going to join this CD, right? I'm going to join the CD here. I move from C to D, or D to E, right? So to form the triangle, right? So you can see that now I have got this triangle, which is the BDE. The triangle, which is the BDE, let me try to highlight it so you can able to see the triangle that I'm talking about, right? This is the triangle that I'm talking about, right? You can see the triangle, which is the BDE, and the triangle, which is the CED, right? The triangle, which is the C, this is the CED, right? This is the triangle, right, in this color. Okay, then I am done with the constructions, right? Then now I have to apply the proof in detail, right? I have to apply the proof in detail. Let's go and do the proof. To prove this thing, what you need to do then now here, you need to select the triangles that you're going to use, right? As the first point, I'm going to use the area. So I'm going to use the area of the triangle, which is ADE, the triangle ADE, right? And divide it with the area of the triangle, which is BDE. Okay, right, I'm going to do that. So let's go back to the diagram and check the triangles that we are doing here, right? Is the area of a triangle ADE. ADE is the first triangle, right? Remember we draw the altitudes H and K in the triangle ADE, right? This is the triangle ADE, okay, divided by the area BDE. BDE is the one that I constructed here. You can see this is the BDE here, which is this one. Okay, so remember that the area of a triangle is equals to half base multiplied by height, right? Okay, so let's go and check this one, the triangle ADE. So in this first point, I'm going to use the first altitude, which is the H, right? I'm going to take the base as the AD here, right? And find the area. So it's going to be half multiplied by the base. The base, I'm going to use the AD at the moment, which is the AD.